Welcome to Altair Engineering Training and Support. In this video I am going to cover how to edit the roll cage data, how to generate a 1D meshing on the roll cage data, line data, and the topics which I am going to cover in this: how to import the CAD file in Hypermesh, then how to move or assign the surfaces or lines in one component if there are several components on your model. Then how to create material, then I'll show you how to create different cross section, that is circular and hollow cross section, how to introduce them, then define the different properties, how to update the different components according to the property, how to do 1D meshing using line mesh panel and how to update that using bar mesh bar panels, then how to view and correct the free 1D elements, how to assign the proper orientation to the elements. Free run will perform to check the elements connectivity and quality, and then view the results in Hyperview to proceed that further. So we'll start our session. So open Hypermesh, make sure you have selected, click on this icon and select the radius bulk data as the user profile. Click OK, and on the top make sure the radius bulk data profile is selected, as you can see here. So it has to be selected properly because you are performing line data structure. So you are performing static analysis, so that's why make sure that it is selected. Then click on import button. To import the CAD file, click on import geometry or go to files, import geometry. Click on the open folder, browse the location where you have saved the IGS file. If you have a different format file, you can select from this drop box which format file you have. According to that, you have to select the file and import it. Then if you created a model in a inches format, then you have to multiply it up with a scale factor of 25.4 to import it in mm. Or if you have created your CAD model in mm, then make the scale factor as 1 and import the same. To check whether this model is in mm or import, before going further I will first check it. So press F4 from your keyboard, click on this any one line and click till that it's the square converted into box, so it will get highlighted. Pick one end node and the other one, so you will find the distance between two. If it's very less, so it's in inches, otherwise if the distance is proper, so it's in mm. So make sure this distance is proper, it should be in mm, because all the other parameters we take will be in mm. So make sure your roll cage data is in mm. You can pick any one line, again press F4 from your keyboard to enter to a line panel, or go to geometry, distance, the same panel, pick any one line and see the distance. Okay. So in this way, make sure the distance is proper. If it's very less, around 17 or 18, so that means your roll cage structure is in inches. So you have to import it again by multiplying with the scale factor of 25.4 and convert that into a mm panel. So this is my model. On the model browser, as you can see, there are multiple components are there with a different component containing different bar sections with the line section, as you can see. So as you can see, if I on this, so there are different, the line segments are in different components. So first I will show you how to move all of them in one single line component. For that, go to component icon here. In component collector icon, select create radio button, enter the component name as roll cage line data. Define an appropriate color, don't give the property currently, and click create. So it will create a roll cage line data component. Click return. Go to tools page. On tools page, click on organize, or press F11 from your keyboard, shift plus F11. This command is used to organize panel. This is the short key. So press tool organize or press shift plus F11 from your keyboard to enter to organize panel. Select the radio button as collector. From the drop box, select surface, or these are the lines, so select lines from the drop box. Select the destination component as roll cage line data. click on lines and say all. So it will select all the lines and click on move. So once you click on move, it will move all the lines. I will change the color of this component. From here you can change the color also. So now you can see if I off this, so none of these components have a line data structure. All have been moved in a roll cage line data. So I will select these from top to bottom and delete all these. So now my model has only one component containing all the line data. Sometimes these type of errors come. I'll show you that. So this is my line data which is moved in one GUI. Sometimes if you import a solid structure, then it will show you two lines. So on that you can't do a 2D mesh. You have to do the mesh on the line data. So you have to create a line data specifically and import it. So I will show you that. So I will import one more data as that is the line data. I will import another one. So if here I have a 2D structure. So if you import a 2D structure somewhat like this, so if you import a geometry which contains the surfaces, so it will show you two lines, something like this, as you can see here. If I change from model, I change the color. So you can see these are the two parallel lines. So this is the surface data. If you on the surfaces, this is a solid data. It's not a line data. So it is used to create 3D or 2D mesh. It is not used to create 1D mesh. For 1D mesh, you have to create a 1D line data structure with the line on the center of this bars, which you can see here. So this is the line data, the single lines. So you don't import this on this model. You have to do 2D or 3D meshing. No, you cannot do 1D meshing on this structure. Okay, so I will close this. Now I will move to the next point, that is assigning the material. So I will assign to assign a material or to create a material, I will click on material collector icon. Enter the material name as steel. Define an appropriate color. Select the type as isotropic, card image as mat1 and click on create edit. Enter the values of E, nu and rho. If you have a different material, we specify you use the same unit. The unit on which values of E, nu and rho are entered here. Nu doesn't have any unit. So the unit which you have nu, E and rho, so you enter the same if you change the material properties. So I have entered the values of steel. If you are using different material, you can enter it in a different way. Then click return to accept these values. Again click return to exit the material collector panel. So on the model browser you can see my material as steel has been created. Now I will define two different cross sections. So I will go to 1D to define the cross section. Go to 1D page. On 1D page click on hyperbeam. First I will create a circular cross section. So select standard section. In standard section select hyperbeam, standard section library, and as a standard section type select thin wall tube. I will create a circular cross section. To create circular cross section select thin wall tube, click create. Enter the values of outer radius as 12 and inner radius, whatever the inner and outer radius on your model as. Input those values. Don't input the dia values. If you have a dia values, convert them into radius and input the values of radius. Here it requires outer radius and inner radius. So make sure your outer and inner radius values has to be entered. Rename it as circular section. Then again go to hypermesh. And now I will create one more, that is thin wall box. So if someone having the thin box structure, that is the square section, hollow square section, then he can also create that and apply on the roll cage structure. So I will create that thin wall box. Enter these dimensions. I will enter as 15, 15, and the thickness will be 3. I'll use the same thickness, and rename it as square section. Then again click on this icon to move again to hypermesh GUI, as you can see there. So click on again hypermesh. So here you can see on the model browser my beam section has been defined. So now I will create two different properties to assign these two beam sections. One is circular, one is square. So to create property, if you don't have square section, only create one circular section, don't create a square one. If you have both, create both. Otherwise don't create both. So click on property, collector icon, click on create radio button, enter the property name as roll cage circular, define a color, select the type as 1D because the element types are 1D, select P beam as the card image, select the material and select the section as circular section, beam section as circular section. Click on create edit to check whether it has put all the values or not. So you can see here it has put all the values of A and everything. So click return. Again click return to exit the property panel. So we have created a property for circular section. Now we will create a property for square section. So I will again go to property collector icon. From the roll cage circular I will enter the value as square. Define a different color to it. Select the type same as 1D. Card image as P beam. P beam stands for property of beam. Material same as steel. Beam section, this time I will select square. And click on create edit again to check whether it has come up with all the values or not. So it has come up. So click return again. Again click return to exit the property collector. So I have defined two properties. So to assign these two properties I will create two different components. So I will go to component panel. This time I will create a component as roll cage circular. From the toggle down button, so I will create a property. I will define here the property of circular. Make sure all these values should be assigned, that is card image as P beam, material as steel, card image as mat 1 should be there. If it's not there, that means you have not assigned material and property. You have to recheck it again. Click on create, so it will get created. Then we will create a square section giving the property of roll cage square and click create. So roll cage square has got created. The values will be, as you can see, you can check it here. We will define some different colors to it. So we'll change the color so that it will be easily visible. Then we'll move to the meshing once my MPC process ends. So after that, after component, I will go to the meshing. So to do 1D meshing on the line roll cage line data, go to 1D page, select line mesh panel. Click on from the drop box, select lines, click on the lines and say all. Click on property and select circular property first. So make sure the areas where you don't want you want square section, deselect those lines. So as I arbitrarily select some more some lines like this, so I want the square section on this. You have to decide where you are putting the square section, so accordingly you have to apply the square section. So I will put the square section here also. Same way I will put some square section here. So on this model I am putting the square section on this. Rest all are hollow circular pipes. So for this I will select circular, keep all the other parameters as it is and click on mesh. So it will mesh it with an element size of 10. I will click return to accept this meshing. But I'll show you, if I make it in a standard section 3D representation, from traditional to 3D representation. So you can see it has moved to a roll cage square component. This color is, as you can see, the color, but the cross section is circular. So it is not moved to the correct component. So I will delete, go to delete panel, delete these elements, click return and right click on it and say make current. So my roll cage circular is the current one. Again I will select shift plus left mouse button and drag, and again I will select all these lines and right click on the line which I want to deselect. So these are the lines I don't want to be a circular one. Select the property as circular again and say mesh. So in this way you can see it has done the meshing. Click return to accept this mesh. Now I will make this as the current. Go to again 1D line mesh, select the property as a square one and select those lines for which I want a square section. So these are the lines where I want the square section, and click on create click on mesh. So once you click on mesh, you can see it will get created a square section. So if I off the geometry, these are the mesh elements. So they have the square section. I will mask a portion of it, mask and reverse. If I move it into 3D representation, you can see this portion has a square section and the rest is having the circular cross section. So in this way you can impose two different cross section in one single file. Okay, so now I will click unmask all, return. Now I'll move to the next topic, that if after the line mesh I will make, as you can see there are some elements, some areas where the meshing is not showing it. It is not showing the meshing, as you can see. But if I move that into a line mode, it is showing that there are elements. So this is because of the orientation issue. So I will update the orientation. So I will one by one pick the lines. So this is the first. So I'll go to 1D bars, go to update and select these. From here we have to, next to this we have to pick these elements. I will again move it to line mode. I will right click it, I will select this, I will select this. Similarly I will select this. So these are the lines where my cross section is not proper. So I will make sure the length is in Y. So my orientation will be in, my length is in Z axis, as you can see. The length of these element is in Z axis. So my cross sectional orientation should be in Y axis, perpendicular to the length. Select the property. This is the square sections. I will select this is the circular sections. I will select circular. Element type I will select as C beam, because they are the beam elements. C beam stands for component of beam, and click update and update all the parameters. Now if I move it in a traditional mode, so you can see here it is showing me the circular cross section. In the similar way, these are the two bars where it is not showing the cross section. So I will again go to 1D page, bars, go to update, press shift and select those elements which is not showing the proper orientation. So these are the bars which are not showing the proper orientation. Similarly on the opposite end, make sure you select all the beams. You can to select, click left. If you want to deselect, click right click on that, so it will get deselected. Select the property as circular, element type as C beam, and click on update. Update all the parameters. Similarly I will move this into traditional mode and see whether anyone is left with. So the top one is also, it is not showing me the proper orientation. So 1D bars, again I will select these elements. You can just left click on it to select the elements. Make sure you select the proper and appropriate elements. Same here also, the length is in z-axis, so we will select the property as circular because they are also circular, element type as C-beam, and just click on update to update the orientation. Now if you move it in a traditional mode, so you can see all the components are showing now the meshing. So in this way you can update this. Now we will move to the elements connectivity. So I will go to analysis, we'll go to tools page. On tools page, click on check elements, or you can press F10 from your keyboard to enter to check elements panel directly. So go to F10 directly. So I will move to the elements quality panel. Press F10 from your keyboard. Select the radio button as 1D because we have done the 1D meshing, so we will check the qualities for 1D. First click on duplicates to find any duplicate elements were there or not. So there are no duplicate elements. Then click on free 1Ds. So as you can see, there are 14 free 1D elements are there. It is on the bottom, you can see it is showing 14 free and 1D elements were found. So click on save field. So it will save all these 14 1D elements which are getting free 1D elements. Then go to mask. Select from the drop box elements, click on elements, retrieve, elements, reverse, and mask. So only those elements are highlighted which are not connected properly. All the elements are got masked. So then press Shift F2 from your keyboard or go to geometry, temporary nodes, and add the nodes. So then again click on unmask all. So these are the areas where the connectivity is not proper. So now I will show you how to connect them properly. So I will start one by one. Again create some more nodes here in between the around that. So you can see if I go to delete panel, this element is having from here to here it is one element, from here to here it's one element, and from here, so this perpendicular element is in between this element, that's why it's not connected. So what we'll do, we'll delete these elements, go to 1D bars, this time select the radio button as bar 2, select a proper orientation. So if it's an incline, so you can select either Y or X or Y or Z. So select orientation as Y, property as circular, element type as C-beam. From this node to this node create one element. Click reject as this moves to the square one, so make this as the current. From this end to this end make a element, from this end to this make another element. Press Shift F2 again and say select these and say clear. Don't click on clear or otherwise it will clear all the nodes which we have created for their reference. Similarly create these and click add. So the same error is here. So delete this two elements, go to 1D bars, from node A to node B create one element, from this node to this node create an element. Again Shift F2 and clear these, select first and clear this. Here also if I go to Shift F2 add the nodes, so you can see this is being connected to this side. So if I go to F2, this is the single element, this is single element, all are the single elements are connected to this node, but this element is connected to a node in between here. So I will delete this element, make as this element is for the square section, so I will make it as make current. Select the property of square, element type will be same as C-beam. From this node to this I will create an element. So I will go to Shift F2 again, clear these nodes, then move to this one. The same error is here, so I will delete this element, go to 1D bars, make sure the roll cage square is current, property as roll cage square, C-beam as the element type. From this node to this node I will create one element. Again shift F2 and clear these nodes. Again I will go for this one, create some nodes, add. So as you can see, here is a minute difference in the connectivity. So what I will do, I will delete all the elements, go to 1D bars. As the square one is current, property should be square, element type C beam. I will pick from this end to this end. Then I will make circular as the current, change the property to circular, select the element type as C beam. So if I put it like this, so the length is in Z for this one, so it will be okay. It's in X, so the orientation Y is okay. It's an angular, orientation Y is okay. For this, the length is in Y axis, so I will change the orientation to Z. Otherwise it will throw the error of orientation. So make sure whatever your element along the length, don't use that orientation. Use any orientation perpendicular to it. Similarly here also I will press shift F2 first, add the nodes. So here also there is very minute connectivity issue. So I will remove these elements. So currently the roll cage circular is current. So I will first create the circular elements, select the property as circular, C beam, and from this node to this node, from this end to this end. So I will create this, then I will make the square one as the current, change the property to square, element type to C beam, from this node to this, shift F2 and clear these nodes. Now I'll move to the lower portion. So in this way you have to edit the geometry, connectivity issues. So I will add these nodes to both the sides. So you can see there is same connectivity issue. This element comes in between these two. So I will delete it, make the circular one as the current, property as circular, C beam, length is in Y, orientation Z is okay. Similarly I will delete it, from the length is in X, orientation Z is okay. So from this end to this end. Similarly go to F2 and delete this, and from node A to this, node A to this. Again I will delete this, shift F, go to F2, from this node my length is in Y axis, so orientation is fine if I orient this. So press shift F2, select all these nodes and say clear. So the nodes will get cleared, the temporary ones. Again press shift F2, add. Here also I will press shift F2 and add. So if this is free, that is correct, because they are not properly connected. They are not connected, they are the extension of my roll cage structure. So it is okay if they are not connected. But the rest all has to be connected properly. So I will delete all these, go to property circular, from this end to this I will create, from this end to this I will create. Similarly here also I will create it. Now I will change the component to square one, make current, change the property to square, element type to C beam, from this node to this, again from this node to this. So I will left this one, shift F2, and this time I can click clear all. Again I will press F10 from my keyboard, click on free 1D. So if two 1D elements are free, that means all are joined properly. So these two are okay if they are free, because they are the extension of my roll cage structure. So it's okay. On this end no other pipe is connected, so it will be free, definitely it will be free. So in this way my connectivity issue and resolution issue is solved. So you can also check it once. So all are showing in a 3D representation. Once the connectivity and resolution is checked, we'll also perform a free run to see all the members are should be connected. To make sure that all the members are connected properly, I will perform a free run, because I'll show you one example where it may be possible the elements connectivity may be differ. So as you can see here, there are 1, 2, 3, 4 elements at the one point. So if these two elements are connected and these two elements are connected with each other, why we are performing free run, that I am going to explain. If these two elements are connected with each other and these two elements are connected with each other, but there is no connectivity between these two, so it will not show you the free 1D, because it will show you the free 1D only when one element is not connected to any other. But if it's connected to anyone, so it will not show you the free 1D. So that we want to make sure that on this point all the 4 bars are connected properly. So for that we need to perform a free run. The free run stands for we will excite this model in some frequency range and check the connectivity. All the beams should move simultaneously whatsoever the frequency range is. So that is not my point, that what is the frequency range. To perform free run, my point is to check the elements connectivity so that all the elements are connected. Okay, so to go for the free run, I will go to EIGRL. First I have to define the load collector, where I will show. So I will type as EIGRL. Enter the card image name as EIGRL. Select the card image as EIGRL to define the frequency range. Then click on create edit. Enter the value of V1, V2 and ND. V1 stands for initial frequency, V2 stands for maximum frequency, and ND stands for number of modes. As I already told you, I am not concerned about the frequency range and the values. I am more concerned about the connectivity. So free run is used for the connectivity, not to find the maximum frequencies or mode of excitations. So I will click return to exit the panel. So you can see on the model browser my load collector has been defined. Now I'll go to analysis, load step, and type here free run. Define the load step to define the type of analysis. Select the type as normal modes. Check the box in front of SPC. Uncheck the box on front of SPC. Check the box in front of method structure to define EIGRL and click on create. So you can see my load step has been defined. Now I will save this file in a new folder as roll cage. Go to analysis, radios to run this file. Keep all the parameters as it is, that is export option to all, run option to analysis, memory option to default, and click on radios. So it will start this. So you can see it's showing some error. So we will check what was the error. So here it is showing that 3082 element has invalid orientation. So I will copy this 3082 number, go to mask element by ID, paste it here, press enter, so it will be selected. I will mask and reverse, so only that particular element is selected. Then I will go to shift F2 and drag the window to add the node. So here is the element with the improper orientation. So if I move it in a 3D representation, so you can see the orientation of this is not proper. So I will go to 1D bars, go to update, pick this element. If the length is in Z, so I have to update or orient them Y. Roll cage circular, this is the circular, so I will make this as the current. C beam and update. Update all the parameters. Press shift F2 again, say clear all. save this file, again go to analysis, radius, keep all the other parameters as it is and click on radius again and ask him to overwrite the same file. So now you can see once you rectify or solve that issue, your message that analysis completed has come. So now you can click on results to see the elements connectivity. So if you click on results, it will divert you to Hyperview GUI where you see the results. So it will, this is the message of license expiry date. So just close this. This is the file, go to contour and say apply. So this is the different modes. Then select animation as linear animation. Click on play. As the deformation is very less, so we will go to deformed. Increase the value of deformation a bit. So here you can see this section is not connected properly. As you can see here, this is moving out of this. So these two are not connected. If I change the mode, here also you can see the bottom one is also not connected properly. So as I told you earlier, even though if there are 4 connections, so maybe 2 are connected with each other, the 4 are not connected with one node, so we have to connect them. So that's why we perform free run. So that is why it is more important. So you can see here that this portion is not connected properly. This portion is not connected properly. So we will connect them again and perform a free run again. Here also at the end you can see these 2 bars are also not connected. Even though it's the extension bar, but this point is not connected to the extended bar. So there are 1, 2, 3, 4, 5, 6, 7, 8, 9 joints where the connectivity is not proper. So I will keep this as it is in the deformed position, so I can easily rectify. So I will start with the rear end. So these bars are not connected with the square section. So I will press Shift F2, add the nodes. So you can see if I press F2, this is the single element, so it is not connected. So I will delete it. Similar the case on the opposite end, this is also a single element. The element has to be from this end to this end and from this end to this end. So it is not like that. So again I will go to 1D bars. The length is in Z-axis, so it's fine. Roll cage circular. Property as roll cage circular, element type as C-beam. Go to bars 2, property as roll cage circular, element type as C-beam. From this end to this end I will create one element, and from this end to this end I will create another element. Similar the case for here, from this end to this end I will create one element, and from this end to this. So this is now get connected. Now I will move to the upside, this portion. I will add a node here. These portions are also not connected properly, so F2 and delete these all 4 elements. So when the length is in Z-axis, so select bar 2, 1D, bars, bar 2, so orientation will be Y will work for all. Select the property as roll cage circular, C-beam. From this node to this node I will create one element, from this node to this node. So I have created all the 4 nodes. So again click clear all. Then I will move to this end. Again press Shift F2 from my keyboard, add the nodes. These 4 joints are not connected, as also the bottom joint is not connected. So I will move one by one. So here you can see there is a huge gap here. So I will delete these elements. Go to bars. From this end to this end I will create one element. From this end to this end I will create another element. This is due to the discontinuity of the line data. So as per your line data it creates the meshing. So you can see the line data is not connected properly. That's why it is not creating the elements. So again I will delete these 2, from this node to this node and from this node to this node. Here also I will delete these two. Go to bars, press F. So from this node to this node to this. But for this one my length is in Y, so I have to change the orientation to Z, otherwise it will throw the error of orientation. So you have to make sure you have selected the proper orientation. So press F2, delete this. Also you can delete this for just for the security. Create it from here to here, change the orientation to Y and select it. So all these top portion is done. So now here is the connectivity issue. So I will delete this one. My length is in x-axis, so orientation Y will work. Also there is no connectivity here, so I will press shift F, only F2. From node A to node B I will create one. Here also the connectivity is not there, so I will delete this. From this node to this I will create one. Delete this one also, and from this end to this end I will create one. So in this way I have created all the connections. So I will click clear all. Again I will click save as, create a new folder here and save this file. Again go to analysis, radius, if I on the meshing, so this is done. Go to radius, keep all the parameters as it is. Click on radius to run the solver. Click on the results as my analysis has got completed. Again go to contour, Eigen modes apply. Increase the deformation scale factor to see the animation more accurately. Select linear transition methods and see the animation. If I put it as 30, so it will deform not much. So just I am magnifying the deformation. So I can see here now it is not deforming. So it is, sorry, it is deforming by connectivity. It is not deforming alone. So you can see here all my pipes are now properly connected, as you can see. So this is most important thing, that all the segments should be properly connected. If it's not, you have to connect them manually the way I have shown you. Just delete those elements and connect from node to node, create new elements and check it again whether all these beam sections are connected properly or not. So in this way my roll cage data is ready to mesh. So we will apply the forces constraint on this and perform the different analysis on this roll cage data. So my roll cage data is now ready with the different cross sections, as you can see, square and circular. With the proper connectivity, everything is done. So my roll cage data is ready to do a different analysis. In this way you have to edit a roll cage line data structure by generating a 1D line mesh. So in this way I have ended this video. Thank you very much.